El cambio climático es una carrera que estamos perdiendo. No obstante, podemos ganarla, porque la crisis climática está causada por nosotros y las soluciones deben de venir de nosotros. Palabras de Antonio Guterres, noveno secretario general de la ONU. Buen día, sean todos bienvenidos. Al asumir que la crisis climática es responsabilidad de todos y que somos nosotros quienes debemos proponer soluciones viables, en nuestro sector reconocemos tener las herramientas y que la tecnología está de nuestro lado, por lo que el día de hoy les presentamos la disrupción tecnológica que nos permite construir carreteras con una mayor vida útil, mejor desempeño y, lo mejor de todo, a un menor costo. RARx, polvo de neumático pretratado y preactivado, rentabilidad económica y ambiental para las carreteras. Neotec Asphalt trae a México la patente del RARx, producto más amigable en su uso e incorporación para potenciar el desempeño de las mezclas asfálticas, que alarga la vida de los pavimentos, reduce costos y pensado para mejorar la infraestructura vial de nuestro país. Además de fomentar la economía circular, economía que es restaurativa, regenerativa y que tiene entre sus propósitos crear beneficios para la sociedad, las empresas y el medio ambiente. Pero para hablar más ampliamente del tema, les presento al inventor del RARx, el doctor Jorge Sousa. Él es ingeniero civil y militar por la Militar Academy de Lisboa, Portugal. Además, es maestro en ciencias en ingeniería civil y doctor de filosofía en ingeniería civil, ambos por la Universidad de California, en Berkeley, Estados Unidos. Bienvenido, Jorge. El espacio es tuyo.
Thank you, Hugo. Hello, everybody. It's really a pleasure to be with you today to present a subject that is very dear to my heart. We have been studying ways of improving wet method asphalt rubber applications, and we have developed RARx to make roads far more sustainable and far more cost effective, with huge benefits for the users. We have been very conscious in developing sustainable pavements, as all others define them, with great environmental impacts, with great life cycle cost benefits, and with good social and functional properties, namely ride quality and friction and safety. This has been achieved in the midst of a reality that we all face, that due to our actions, the greenhouse gas concentrations have been exponentially growing in the post-industrial area. It is that makes us realize that we are in a path that is not sustainable. We are currently at CO2 emissions today that have not existed in the world at least for about 1 million years. We need to control that and realize that these emissions caused by fossil fuel combustion has been exponentially increasing since the time of post-industrial revolution. We need to control that because otherwise the temperature in this planet is rising at alarming rates. We know that this is not going to stop, and the consequences of this global warming are many. One, for instance, is that probably Greenland will melt if we don't do anything. And besides that, we have Antarctica also melting. And this will cause high sea level rises. This has been widely documented. And you may hear that it's controversial that Antarctica is losing, in some parts is gaining, but it's clear that the net loss of Antarctica is growing as climate change is progressing. We need to control that because the latest prediction indicates that we are now on a path that we will have extreme too high levels of sea level change. So by the time our kids are in control of the world, then we're going to have a planet where the ocean levels are about 1 meter higher than they were in the time of our time, or time of our fathers. This is caused profound effects. For instance, in US, property near the coast in Florida is now starting to lower values because they know that they're going to lose the houses. We need to realize that this is a global trend and has been predicted. And far more, the predictions have been corrected up to now. You can see in Mexico that you're going to have 6 to 7 degrees in average more. And you can see many planets of the world going to be tremendously impacted. And you can see that this is already happening. You can see that since 2012 to 2016, we have seen temperature rising of the order of 2 degrees. And I want to point out that Amazon is going to be so hot that it's very likely to become much drier, and with that, we're going to lose the forest. This is also evident by this graph where you see the level of change in the rain seasons, and you see Europe is going to be very dry, and so is Antarctica. So is Amazon, and you can see Mexico is going to be strongly affected. You're going to have less rainfall and probably strong influence in the plants you're going to be growing. Other examples of the global destructions occurring is the example of Puerto Rico, Maria in 2017. The devastation was great, and you can see, for instance, that this very nice bridge was totally destroyed. And I ask you, if that bridge was done with asphalt, with warm mix, do you think we would have saved anything? I don't. I think that there is technologies that need to be considered on the large scales and how important they are to have disruptive effects on the savings we are having. For instance, you can see that there was significant destruction caused by the hurricane that could have been prevented if we had not global warming. And these kinds of destruction is going to be just ever more present. So, with mean temperatures increasing with records this year, July 20, we had records in US, and we have record droughts in US. This is happening now. The consequences are to be paid now and more as years to come. So global warming is real. It's caused by CO2 and other emissions. There's nothing to be disputed here. If we don't control emissions now, we will have more extreme weather and drought and sea level rises. This is a fact. This is not politics. This is not imagination. This is as clear as day and night. So, we have to do is to stop, minimize CO2 emissions and others. We must develop construction methodologies that reduce CO2 emissions. And we have to develop sustainable construction practices, reuse resources, and use waste flow streams. This is not something we have an option. If we don't do this, the planet will be strongly affected. So, this is so important that for the first time, a president, it may become president by the time you listen to this presentation, he said that we should transition out of oil industry. It has to be replaced because if we don't replace oil emissions, we're gonna leave this planet in a very bad shape. So we have to do global warming versus sustainability evaluations. We have to face the reality. So we cannot ignore it. Burning fossil fuels is the elephant in the room. It's not tremendously effective if we're trying to just consider the little mouse problem of little recycling and little reuse. Either we do it in a big scale, or we're going to have to suffer dire consequences. So we are burning fossil fuels, and we must stop it. The cause of the climate change are not consequences of our direct construction practices. They are a cause of burning fossil fuels. So if we do the same thing or better without burning fossil fuels, we are a winner. So can anybody guess what this is? This is a picture taken very recently. This is how they bring coal from Mongolia to China. Listen, you look at this picture and you worry, okay, do we have warm mix in that pavement? Are we saving something by using warm mix to make this pavement versus regular mix? It's fantastic that we worry about little details when the big picture is so amazing. So we have to take into account that the GDP per capita, and this comes from the CIA website, countries that have been producing oil, like Angola, where I'm from, Venezuela, Libya, the GDP per capita is smaller than countries like Portugal, Greece, Argentina, Italy. So why would we care at the level of the countries that we are using oil or not oil? Oil for these countries has not brought any benefit. So we have to change. We have to move away from using oil and using renewable energy. And with that, I have to tell you something. Right now, I'm making this presentation sitting there in my office in Consulpav. And I just recently placed solar panels that are now feeding my electrical car, and all the electricity we consume during the day in Consulpav comes from solar panels. I have reduced electrical payments from 200,000 euros per month to 500 euros per month. I have free energy to drive my car, and I have zero carbon emissions. This is a little example on a normal country where a company is literally now just taking advantage of the free energy that the sun gives us. This can be applied in many cases and many places. So let's think that for the sake of it, we figure out a way of making solar power pavers, solar power moving equipment, and solar power plants. So there it is. Right there, we have became free of oil dependency. We have unlimited energy, and we create sustainable pavements. But we can go further. We can use the technologies we have to benefit some pavements. Now, many in US have still forgetting the big picture, considering warm mix technologies and use this technology as a solution for global warming. But we know that our mix has some problems and it really is not tremendously effective. So we need to think further. We obviously need to recycle pavements. We need to use as much recycled as possible. And this is for sure an area where we need to improve testing and quality control standards because the mixes are to be tested. The materials are to be tested with these new materials. But now the benefit of it is that we have performance-based specifications. We have performance-based tests. Presumably, we are supposed to make mixes, test those mixes, and understand how they're going to perform in the field. So just let's use the materials and see how they perform, and use those that perform well. Now, as we wait for all these performance to be evaluated, we have now a technology we can use today that has been demonstrated by the last 50 years that is excellent. Asphalt rubber is very strong in sustainable solutions. We have, as you can see, read about this, many benefits by using asphalt rubber. It's not a new thing. It's not an invention. It is a fact. It's been very well documented, and to the point that in California, all the surface mixes pretty much only have asphalt rubber. So if they benefit, we can. In Arizona, they have demonstrated that instead of using 140 millimeter thickness layers, that is equivalent of using 45 millimeter thick layers with asphalt rubber. How much CO2 are we saving by using one technology versus the other? And this is proven. It's not, you don't risk anything by adopting these technologies now. No risk. It's risk-free. It's just benefits. So, as we are here, we have now those performance-based tools, and these are the results of flexible fatigue tests. Under the N, you see all the normal mixes that you have with polymers, with SMAs, with dense mixes. You barely see the fatigue life of these mixes down there. But if you use asphalt rubber mixes, the wet method, the conventional method, is like in A. A has 10 times more fatigue life than B. We can use now, with this RARx, the amount of RARx we place in mixes to match the properties of the mixes with wet method. It's like A is B. B is RARx. Now, we can go further. We can even now put much more RARx in the mixes and have performance that never existed before. Actually, in many countries in the world, they have already placed these mixes and they are performing excellently. So we have now ways of taking advantage of the flow of the tires. We place them in pavements and we have a much higher fatigue life. Much higher life for these roads. We can make them with thinner levels. And we can see that by you looking at how the bitumen content, binder content varies, and we see the benefit in fatigue life. You can see that in blue line, you have the actual fatigue test results. And in the red line is the performance prediction done by the Shell. They invented these processes of predicting fatigue life of mixes based on the binder content and the stiffness of the mix. So it's clear that the more you put, the better performance you have. And you see that the benefit is exponential. So a little more gives you a better, much better fatigue life. So let's take advantage of it, knowing that the performances are a little shy, they are conservative, and that the fatigue life with RARx and binder together matches perfectly the predictions done by using the Shell method pretty much indicating, and this is the amazing part, is that by placing rubber in the pavements, they perform like bitumen. So the mix bitumen plus rubber plus RARx is actually just behave as bitumen from the point of view of resisting fatigue life. So it's to the point where we have done now new specifications in Portugal, and we define the quality of a mix, and we specify this based on the fatigue of the mixes. So we have 6 levels of fatigue lives here, now 5 levels, and it's working very well to take advantage of the performance-based tests to determine the quality of our mixes. This brings us to Mexico again. You can go and see this road. It's in the highway to Lacingo, 40 kilometers to Pyramids, and I was lucky to be involved in proposing these solutions. The pavement was very cracked, like most pavements are as they age, and they tried to define what to do. Based on the ASHTO procedure, ME, it indicated that pavement needed 18 centimeters overlay because they don't have a methodology to take advantage of extremely good performing materials. So based on our experience in the models, we identified that 6 centimeters of the gap grade mix with the RARx would be enough to resist the reflective cracking. Given that the pavement, the foundation was good, the slabs are still there, and they will resist the traffic. We just needed to control the reflective cracking. So these have been based on reflective cracking overlay design. You can see that the blue line is indicating less stiffness, much less thickness for the same levels of fatigue. We need to realize that this was a successful project, and if anybody just doesn't really believe in anything I said up to now, just go drive that road. If you see cracks, I'm wrong. If you don't see cracks, I'm okay. So let's compare for that project which sustainable solutions do we have. Now, this is the new way we do things in Europe these days. They have many ways of looking at sustainable projects, and you can see that fact that we have reduced the thickness has benefits in not only the climate change, as you can see on the left, but in ozone depletion, in particle matter, in acidification, in land use, freshwater ecotoxicity, acidification. So this use of recycling rubber into pavements is a huge benefit in all fronts, and it should truly be implemented. One other way of showing that is that we have these all little bars summed up, and you can see that the one in the middle was designed for 5 centimeters conventional mix plus 5 centimeter RARx. Unfortunately, I don't have the one which is just 6 centimeters RARx, which was applied, but you can imagine that is probably half of what is in that bar there. So strongly indicates environmental benefits by using this technology. This is not something, as I said, new. In 2014, the Cal Recycling California have demonstrated that pavements with rubber last about 7 years more. It's why they all mandate now that the surface cores in California must use rubber. They are saving money. So let's look at this also from the point of view that chip seals that perform better are those that have rubber. All the mixes that perform better are those that have rubber. So this has been very well documented in this use of stress-absorbing membranes, and also the combination of stress-absorbing membranes with overlays. So we now come back to just showing you exactly the powder that is pre-cooked, pre-reacted, and activated rubber. It is like a powder. You pretty much replace the filler with this powder to get these super performing mixes. And with that, you just have a silo, like any other silo, where you place the powder and then you put it directly in the pug mill. No need to react anything on site, no need to spend time. You just use it as a filler, except it's a filler that has these great properties. So no need asphalt rubber equipment, no need to do any of that wet method procedure, which is very good. Okay, I'm not taking anything away from it, but now it's just simpler. It's just a much easier way to produce super performing mixes. So we have now the concept of semi-wet method, which is the best of both worlds. Great properties like the wet method, but it's applied like the direct method. We have done this in many countries. In Mexico one, and it is now, this slide is a bit older, and we have now many more roads in Spain that have been using this technology. So you can see that in Michigan, we applied RARx in a plant. Very easy, it's just a powder that comes from a silo, and it can be mixed as it is here with the wrap mix and goes to the plant. This was the first time it was done in US and was a great success. There was no complications and we got a great mix. That mix went directly into these big tank, these big pavers, and is there very successful. We also have applied the RARx in the application of this SAMI, in this case it's a SAM, surface treatment, where pre-coated chips are applied over asphalt rubber, which was made inside that tank. This is a very powerful technology. It creates very durable surfaces, very flexible surfaces that will last a long time. I strongly suggest you use this technology in Mexico. And why this works so well, you can see that the control and the recovery, when you have 35 to 40% RARx, the binder is virtually elastic. You see, percent recovery is close to 100. So for the first time, you have a binder, when it cools down, it is like rubber. So it lasts a long time and it does not have a great fatigue life. This was done, it has a great fatigue life. This has been applied in Indonesia over slabs, and they lasted a long time because they have, again, that you see that percent recovery, about 93 to 95% recovery with great PG life of about 100 degrees C. With performance, or mixing with this performance, it's very easy to understand why they last so long. It's not that we don't have a possibility to control them. They're very easy to control, and you can see that they have all the procedures to apply a mix like all other ones. So when do you have the best mixes ever? When you have rubber. It's very simple. You can always make better pavements with asphalt with rubber. Now, this is very obvious, but let's now think another way. Tires. What can we do with tires? We can burn them. Let's make an example. Here is the data from Caltrans. If all the tires done in Caltrans were used in roads like this government mandate, we would have now the advantage of gaining about 300 to 400 BTUs per pound, which means with that energy is the equivalent of having all houses, 70 to 90% of the California houses, energy for free. This is an amazing amount of energy we can save by using rubber in pavements. So this is very easy. We have sustainable constructions. We have use of rubber, use of oil, use of recycled materials, and in the future, I'm sure we're going to use the energy from the sun to make these roads. But from now, you can already make sustainable roads with rubber. We need to think if all roads were rehabilitated, construction with RARx, would Mexico save enough energy to provide electricity to all its inhabitants? How much more sustainable would this be than current practices? How much energy, CO2, would be saved? This is a challenge I leave for you. I have absolute confidence that they have fantastic brains in Mexico that can dig up all this information and determine if indeed RARx is a sustainable road construction and maintenance best practice. Because if we can save this much energy, we are on the road of sustainability. Thank you so much for this opportunity to share these ideas with you.
Jorge, muchas gracias por tu presentación, que sin duda ha sido muy convincente. Esto es un gran avance en pro de los pavimentos asfálticos y, desde luego, del cuidado del medio ambiente. Muchas gracias.
Hugo, quem agradece sou eu. Foi um prazer estar aqui com vocês. Estou à vossa disposição para implementar esta tecnologia com vocês em México. Um prazer.
Gracias, Jorge. Buen día. Aprovechando la explicación que Jorge nos compartió, quiero comentarles que en México ya se han realizado varios proyectos exitosos con RARx. El primero, en el APP Pirámides Tulancingo, concesionado a CIRTEC de México, dando como resultado una carretera de estándares internacionales. El segundo también es un APP concesionado a la empresa R&M de la autopista Querétaro-San Luis. Otro más con la reciente licitación del Grupo Aeroportuario del Pacífico para rehabilitar las pistas de rodaje del aeropuerto de Guadalajara. Y una más en Avenida Acueducto, una de las vialidades más emblemáticas del municipio de Zapopan, Jalisco. Así que ha llegado el momento de emprender audaces acciones colectivas, a menores costos, para evitar que el cambio climático alcance niveles irreversibles. Y en Untitled Asphalt estamos listos para atender sus proyectos de pavimentos asfálticos y aumentar la rentabilidad de sus negocios con estas acciones audaces. No duden en ponerse en contacto con nosotros, visitando nuestro stand virtual o comunicándose a los números que aparecen en estos momentos, así como nuestras redes sociales. Los invito a formar parte del cambio que nuestro mundo necesita. Untitled Asphalt, una nueva vida para un largo camino. Muchas gracias y que tengan un buen día.